Welcome to Aryavat Center for Theoretical Physics. This is another video on this lecture series called Special Theory of Relativity. In the last lecture, I have derived Lorentz transformation. How we can derive Lorentz transformation from basic assumption of special relativity. And this is the consequence of Lorentz transformation. Consequence of Lorentz transformation will be space or Lorentz contraction and time dilation. So this is the explanation of space contraction or length contraction. Suppose there is a moving bus and we assign moving bus as S dash frame and there is a platform S. In the moving bus there is a rod which is at rest with respect to the moving bus, and the end point of this rod is x1 dash, x2 dash, and when observer measure the length of the rod in this moving bus, it will be L naught. So x2 dash minus x1 dash is L naught. This is in the moving bus frame, S dash frame. Now observer O1 which is on the platform also measure this moving rod, length of this moving rod. So according to Lorentz transformation, x2 dash will be seen by the observer O1 on the platform S as x2. So x2 for the platform S and x2 dash will be platform what you call platform or bus S dash, and it observer O1 which is on the platform S is measuring x2 end point x2 at time t1, and end point x1 at time x2 at time t2 and x1 at time t1. So according to Lorentz transformation, x2 dash will be x2 minus vt2 divided by 1 minus v square c square root minus x1 dash will be x1 minus vt1 divided by 1 minus v square c square root. So this is the length, this is the end point of the rod seen by the observer on the platform S. Now L naught is the length of the rod moving in with respect to the moving frame S dash, and L is the length of the rod as seen by the observer O1 which is on the platform. Now when observer O1 measuring this rod with this moving rod, it has to measure the end point of the moving rod at the same time. It means T1 must be equal to T2, so that x1 and x2 this end point will be measured simultaneously. It means T1 equal to T2 and x2 minus x1 will be L. So this Vt2 Vt1 this will be cancelled it out. So we are left with L naught is equal to x2 minus x1 divided by 1 minus v square c square to the power half, or root 1 minus v square by c square, and x2 minus x1 is L. L is the length observed by the observer O1 which is on the platform S. So L equal to L naught root 1 minus v square by c square, and you can see that the observer O1 on platform S will find the length is contracted by factor root 1 minus v square by c square. It means the observer O1 will find this length as short compared to the observer in the moving bus. So this fact is called space contraction or length contraction or Lorentz contraction. L naught is the length measured by the moving frame. L is the length measured by the unmoving frame. Strange prediction of Lorentz transformation is time dilation. What is time dilation? Take the same example, moving bus and platform, moving bus is S dash frame, platform is S, and in both this frame there is a clock C1 and C2, and there is observer O1, and in O2 observer O2, which is in the moving bus, sending a two consecutive flashlight at time T1 dash and T2 dash. So time interval will be T0 is equal to T2 dash minus T1 dash, and position of this clock is X dash 00. This is the coordinate of the clock inside the bus, and same event will be seen by the observer O1, which is on the platform. So T1 is equal to gamma T1 dash plus Vx dash divided by c square, T2 is equal to gamma T2 dash plus Vx dash divided by c square. This is the according to Lorentz transformation. Now time interval for the S perspective will be T is equal to T2 minus T1, and we subtract these two, we will get gamma T2 dash minus T1 dash. And remember, T2 dash minus T1 dash is the time interval for the observer in the bus, which is T0. So T is equal to gamma T0, or T is equal to T0 divided by root 1 minus V square by C square. It means this equation tells that moving clock runs slowly compared to the unmoving clock. So observer on the platform S will find longer time interval between two events compared to this moving observer. So this is called time dilation.